Allow me to share with you my vision for the university. I envision PUP to become the pioneering and leading national polytechnic university in the 21st century. With a national polytechnic university status, it will bring more opportunities for the university to further strengthen its academic programs and improve organizational performance as an institution for higher education. In pursuit for this vision, my mission for PUP is for it to recognize its catalytic role for national development. PUP will ensure inclusive and equitable quality education and promote lifelong learning opportunities through a re-engineered polytechnic education. By re-engineering, we look into the existing processes and programs in order to achieve higher quality of academic programs and services following the principles of effectiveness and efficiency. With this mission in mind, I have formulated 10 pillars as my reform agenda for the university. Pillar 1. Dynamic, transformational, and responsible leadership. Empower academic and administrative leaders by following the core principles of good governance to create collective growth and unity. Here I would like to highlight an innovation by introducing the development of an integrity management plan to assess, plan, and implement anti-corruption strategies that will secure the institution against corruption and abuse. Likewise, asset management and resource generation will be aggressively pursued to ensure productivity and finance the implementation of the plans and projects for the university. Pillar 2. Responsive and innovative curricula and instruction. We aim to provide world-class polytechnic education that responds to national and global needs by developing intellectually challenging curricula and design academic programs that are based on industry demands to provide the learners with adequate and relevant competencies and skills and prepare them for a successful and rewarding careers. In a rapidly changing world, we recognize the paradigm shift in curriculum to outcome-based education with lifelong learning approach. Pillar 2 also sits on the framework of internationalization of Philippine higher education through transnational education by promoting academic mobility among faculty and students and global dimension into the curricula and teaching process. Pillar 3. Enabling and productive learning environment. Following education in Industry 4.0, we aim to increase and enhance the use of new technology to enable student learning and engagement, as well as advanced teaching process and methodology through new and state-of-the-art facilities that will support the overall learning and teaching experience in the university. Pillar 3 likewise includes campus development and the provision of conducive learning centers and facilities for students and faculty. Pillar 4. Holistic student development and engagement. We will empower students as well as rounded learners and active young leaders as we open opportunities for various academic mobility and venues for honing skills and personal development, being the principal stakeholder of the university. Recognize academic freedom as a form of self-expression and a platform to showcase students' intellect, skills, and creativity. Pillar 5. Empowered faculty members and employees. Likewise, we are looking into the holistic development of our faculty and employees as productive, competent, and experts in their respective fields. We will encourage our faculty roster through formal education, capacity building, research and extension initiatives, faculty immersion, and other academic engagements, both local and abroad. We will ensure that both our faculty and employees will have a vibrant career development path as public servants in this state university. Pillar 6. Vigorous research production and utilization. We will continue to strengthen the research culture in the university by promoting discovery and innovation through increasing disciplinary and collaborative research integration across academic disciplines to create new knowledge, utilize research findings, and develop innovative products. Pillar 7. Global Academic Standards and Excellence. Achieve the highest levels of recognition in quality and compliance standards from CHED, AACUP, and other international accrediting and regulatory bodies for higher education. We will intensify our efforts to achieve and sustain better academic performance and continue to excel as a top-performing school in various professional licensure examinations and produce board top-notchers, as well as sustain our status of being the most preferred graduates of employers. Likewise, we aim to establish and to be recognized as centers of development and excellence in our academic programs. Pillar 8. Synergistic, productive strategic networks and partnerships. Synergize and forge strategic linkages and partnerships across all sectors of society and the global community in line with the overall plans and programs of the university. Establish alliance with the government, industry sector, NGOs, and the academe will lead to resource sharing, program support, and research collaborations beneficial for all. Pillar 9. Active and sustained stakeholders engagement. Harness a healthy and harmonious organization by empowering all its stakeholders, both internal and external, through open communication networks, consultative and participative undertakings, and team-building activities, recognizing that all stakeholders can greatly contribute towards the betterment of the university. Pillar 10. Sustainable social development programs and projects. Expand access to education, knowledge building, and information dissemination through sharing of expertise and resources for community development. Support inclusivity approach in education by embarking on Education on Wheels, which aims to bring access to education closer to communities, following the principle of no one will be left behind. As the University of the People, we should bring the university closer to their hearts to serve their needs and extend assistance in mainstreaming public service. Our institution must continue to stand as one for the values that we have inculcated. For the past 115 years, we have exemplified our quest for truth, excellence, equity, relevance, effectiveness, integrity, and academic freedom. Lastly, I call upon each and everyone to join me in this journey. Together we stand as one para sa sintang paaralan para sa ating bayan.
Good morning, everyone. Welcome to the Professorial Chair Lecture Series 2020 This is the 8th session. So let's all feel the presence of the Lord for the doxology and the national anthem.
Noon pa man, malaki na ang naging bahagi ng mga kababaihan sa lipunang Pilipino. Kaisa sila sa marubdob na paghahangad ng kalayaan ng ating lahi. Kabilang sila sa paglinang ng ating makulay na sining at mayamang kultura. Kasapi sila sa pagtataguyod ng mga adhikain ng kapwa mamamayan at sa pagtugon sa mga pangangailangan ng lipunan. Katuwang sila sa pagtuklas sa mga larangan ng agham at medisina. Kapanalig sila sa pagpapairal ng batas, karapatan at katarungan para sa lahat. Kabahagi sila sa paglilingkod sa bayan at sa pagpapanatili ng demokrasyang Pilipino. Sa paglipas ng panahon, hindi nagmaliw ang kanilang pag-ibig sa ating inang bayan. Mga kababayan, ito ang alay ng mga kababaihang Pilipino para sa bayan. Tumayo po tayong lahat at sabay-sabay nating awitin ang pambansang awit ng Pilipinas.
Kayang mag-iliw, pero sa silanganan, alam ng puso, sa dilim mo'y buhay. Lupang hinirang, dulatan ng mag-iliw, sa manlulupin, di ka masisigil. Sa lahat ng tulog, sa sigat at sa lalim mong babang, magilang ang tula at awit sa paglayang minamahal. Ang isang ng patawad mo'y tagumpay na nagniligid. Tuwing at araw ng kailan pa may madilig. Lupa ng araw ng 100% buhay ay langit sa piling mo. Ang higaya na pag ay makahamit, ang mamatay ng dahil sa'yo.
Okay, so welcome everyone. So before we start our program, we'd like to remind everyone of the virtual conference etiquette. First, kindly change your Zoom meeting ID to this format, the acronym of the institution you are affiliated with, your full name. Otherwise, you may use your full name as the meeting ID. Remember that your microphone and video camera are disabled by default. So you may enable them if it's your turn to interact. Kindly be respectful. Don't interrupt the presenter and keep your mic on mute and camera off while someone is presenting to avoid unnecessary distractions. Also, be an active participant, provide inputs, and respond to the speaker's request for comments or questions.
Questions. Okay, next. Okay, ako na.
Kindly change.
Next po. Ako na. Sign ka na. Change your Zoom meeting account. Tama ba? Change your ito. And questions and clarifications will be entertained after the presentation. You may use the chat box for the affiliators to note them. State your name and institution and ask questions concisely. Comments that will benefit others are most welcome. Provide feedback. Help us improve our online events to better understand your needs and preference. For our registered participants who are on Facebook, make sure that you have answered the survey feedback to ensure that you will receive an e-certificate. Whenever disconnected in the Zoom meeting, please log it again using the link, or you may join us at www.facebook.com PUP Alumni Officials.
Okay, to deliver our welcome remarks, may I call on the College of Science Dean, Dr. Lincoln A. Bautista.
Hindi po. Ayan. Ma'am Josie, narinig na niyo po ako?
Yes, sir.
Yes, sir. Okay po.
Good morning to everyone. Good morning to President, our PUP President, Manuel Muhi. To our resource person today, Chancellor of PUP Diliman, Dr. Fidel Nemenzo. I also seen Sir Ramir Cruz and other officials of PUP. And to all the participants, magandang umaga po sa inyong lahat. Ito na po yung ating pinakahihintay na lecture series ni Dr. Nemenzo. And we are quite intrigued with the title of this topic, numbers and curves. When we talk of a curve, parang ating unang naisip ngayon yung flattening the curve, o kaya fattening the curve. And of course, we will be enlightened by his talk. And ako po ay personally excited na mapakinggan ko muli po ang lecture po ni Dr. Nemenzo. I last heard about him po sa, I think sa MSP pa, National MSP. But he always fascinated us with his talk. Marami po tayong matutunan sa kanya at tayo po ay makinig at tayo po ay makiparticipate na mabuti. Ang PUP po ay nagagalak dahil po tayo po ay napagbigyan po ni Dr. Nemenzo at tayo po ay palagi pong sumusuporta para po sa ikakaunlad at ikakadagdag pa ng ating kaalaman para po sa ating sintang paaralan. Muli po, magandang umaga po at tayo po ay blessed na blessed dahil po sa ating pong pagkakaroon ng lecture series ngayong umaga. Thank you po. Ma'am Josie, sa inyo na po.
Thank you, Sir Lincoln. So, let me introduce our speaker for today. Our speaker is a professor of mathematics and the Chancellor of the University of the Philippines, Diliman. He studied in UP Diliman and Sophia University in Tokyo. where he obtained his Master of Science and Doctor of Science degrees in mathematics. His areas of research are number theory, elliptic curves, and coding theory. Among the awards that he have received are the Achievement Award in Mathematics from the National Research Council of the Philippines and the University of the Philippines Diliman, Gawad Chancellor para sa pinakamahusay na guro. He was also a president of both the Southeast Asian Mathematical Society and the Mathematical Society of the Philippines. And he has held different researches and teaching posts in Singapore, Tokyo, Amsterdam, Munich, and Phnom Penh in Cambodia. In 2019, Dr. Nemenzo was elected to the governing board of the National Research Council of the Philippines and chairs its mathematics division. So ladies and gentlemen, our professorial lecturer for today, Dr. Fidel R. Nemenzo.
Magandang araw sa inyo lahat. Magandang umaga. Magandang araw kay Presidente Bong. Maraming salamat sa imbitasyon. Hello, Jackie. Naririnig niyo ako?
Apo,
Yes,
sir.
Narinig po namin kayo, sir.
Sandali lang, mag-share screen ako.
Yeah.
Hello, Nini. Ayan, magandang umaga sa lahat. Maraming salamat sa invitasyon.
Good morning, sir.
Alam niyo, parang homecoming to dahil hindi, siguro karamihan hindi alam to na ako ay isang former faculty member ng PUP. Nagturo ako dyan bilang lecturer ng mathematics noong 1986, 86, 87.
First year lang ako.
Napakakakan. Masayang karanasan sa akin dahil ito ang trabaho ko bilang lecturer ng mathematics sa PUP ay ang kauna-unahang kong trabaho sa buhay. Kagagamit ko lang. I'll give a talk on numbers and curves. No? Ako po ay isang mathematician. Isa pa akong pure mathematician. No? May babanggitin akong ilang bahagi ng applied math. No? Pero bagamat nitong nakaraang 10 taon ay karamihan ng aking papers ay nasa applied mathematics, in particular sa coding theory at robotics. Gusto ko saan balikan ang aking first love, which is number theory, which is an area of pure mathematics. Gusto ko lang sana pakita ang kasi ako ng picture ng mga teaching experience ko sa PUP. No? Ito lang ang nakita ko. Pagkatapos ng semester namin ay inaya ako ng aking math class, no, sa beach. No? Hindi ko alam kung saan sila ngayon, pero ito yung mga students ko noong 1987. Tingin ko 1987 to. Sige. Diretso ako sa aking mga main points. Nakikita ba niyo?
Yes po.
Yes po.
Yes po, yes po.
You know, one of the biggest challenges of teaching mathematics is really to reveal the ideas behind the formulas. No? Dahil ang karamihan, pag nilisip lang mathematics, ang nakikita nila ay numbers and formulas at obstacle course lang, no, sa eskwela. No? But real mathematics is about ideas. What is mathematics for? I think you do not need to understand the mathematics, but every educated person should at least appreciate the power of mathematics in our world. Many of nature's secrets is revealed to us using mathematics. Our world is, exhibits a lot of order, a lot of disorder, and scientists use mathematics as the language with which to understand and explain these secrets. For many mathematicians is a source of delight. No? In fact, kapag tinatanong ng mga tao, ano nga ba matematika, sinasabi nila, it is a study of numbers, no? Or the study of formulas. No? But mathematics is not only about numbers. Numbers are just some of the tools that we use to study patterns. Mathematics is really the study of patterns. No? And the study of patterns gives mathematicians a deep sense of delight and joy, because it is just like the other arts, it is a creative activity. But unlike other areas, which are sources of joy, mathematics is extremely useful. No? Hindi natin kailangang intindihin ng physics, pero at least kapag nakasakay tayo sa isang umaandar na sasakyan, sana alam natin na matematika ang nagpapatakbo ng mga sasakyan. Siyempre, matematika, nandiyan ang physics, at gamit ng mathematics at physics, no, nag-invento ang mga enhinyero ng mga makina. No? But it's mathematics that powers engines. We cannot power an engine, we cannot design an engine without an understanding of differential equations. We use technology every day to transmit information. All our cell phones, use a lot of mathematics. This is Sudoku. Sabi nila, it is numbers without math. No? But if you look at this game, the number 6 on the top left corner has nothing to do with sixness. Wala siyang kinalaman sa numero 6. Isa lang siyang simbolo. No? Kaya ang game ng Sudoku ay hindi magbabago kapag palitan natin ang bawat numero ng corresponding letter sa alphabet. No? It's essentially the same game. In fact, we do not have to use letters or numbers. No? We can use any set of 9 different figures. This is exactly the same game. So Sudoku is actually math without numbers. We do not use the numbers, but it is all a matter of understanding and making sense of patterns. Kapag applied mathematics ang pinag-usapan, we talk about mathematical models. No? A mathematical model is just a description of a natural or social phenomena. Halimbawa, weather, you know, or movement of cars, of movement of or gravity, the movement of heavenly bodies, you know, the behavior of water flowing out of a faucet. You know. Scientists make accurate descriptions of these phenomena and make predictions using mathematics. No? Ang ginagawa natin is to create mathematical representations kapag nakakakita tayo, halimbawa, or COVID. We look at the system and make assumptions about that system and translate the situation into a set of mathematical concepts and formulas. No? Once you represent a system with mathematical formulas, then you can do your mathematics and arrive at mathematical results. You interpret these results in terms of the original real-world problem. Mathematical modeling is not new to us. Not every school student has an idea of what mathematical modeling is. Halimbawa, ito, usual problems sa trigonometry o sa algebra, Actually, pati sa calculus, no? You have a lamppost, you have a man standing there. We can ask if we know the height of the lamppost, we know the height of the man, we know how far the man is from the lamppost. No? Do we know the length of the shadow? So this is a real world situation, and then we represent it using equations, and we are able to, without measuring the shadow, we are able to make a prediction of how long that shadow will be. You know? This is what we do in mathematical modeling. You translate a real world problem into equations that you can manipulate so that you can make predictions. You know? In fact, sa calculus, if the man is moving, we can also calculate the rate at which the shadow is moving. But of course, your model always depends on your assumptions. No? Problema dito, ito, actually, this is not a very accurate description of the real world. No? You have to make a certain assumption here. When you say that 16 feet is the height of the lamppost, no, the light source, no, should be there at the end of the 16 feet. Kapag sabihin natin the height of the man is 6 feet, no, you have to assume that the ray of light passes through, the top of the head. But we know that since the head of the man is round, the light ray actually passes through a tangent point, not at the top of the head, but somewhere. Diba? Tangent yan. Kaya tuwing gumagawa tayo nito, these are inaccurate descriptions, but they give us some sense of how long the shadow will be. In fact, ang tamang assumption dito is ganito kahabang anino kapag yung ulo ay patulis. No? Kaya kapag sabi natin 6 feet, 6 feet yan from the ground to the point of tangency. So mahalaga dito yung assumptions. No? Your results, your interpretation, your predictions are only as good as your assumptions. Math is used in many ways. How is math used in the time of COVID? Well, mathematicians, molecular biologists, actually study viruses and study the geometry of viruses to understand how they behave. If you want to develop treatments about the virus, you need to understand the structure of the virus. And molecular biologists are teaming up with mathematicians to make accurate models or mathematical representations of viruses. Ito yung sinasabi kanina. When we say curve, now we hear about flattening the curve. Mathematicians and epidemiologists use a lot of public health data to be able to give predictions about how the rate of infection and when the curve will flatten. Ibig sabihin, the rate of infection medyo nagplaplato na. This is very important because if we have predictions about an epidemic, we are able to plan better. We are able to craft a policy that will help us avoid lives while minimizing costs. Some years ago, I was very fascinated by an article in a mathematical journal. The article was about topology. Naalala ko ang pamagat niya ay heart attack or cardiac arrest is a topological problem. Because cardiac arrest, of course, is in a sense a function of many things. And one of them is it's a function of the contractions, the expansions, the movement of the human heart. And in that paper, they were able to make correlations between topological models of the human heart and the actual behavior of the human heart. This is very important when you design artificial heart valves. You do not experiment on live human hearts. But a lot of the experimentation in new technologies in medicine are now done using mathematical models. Pinapakita ko to, gusto kong pakita na ang math ay gamit natin araw-araw. Kinatatakutan kasi ng mga students niya, saan nga ba gamit ng mathematics? No? Ang pinag-aaralan natin ay yung lengguahe ng mathematics, all these equations, but all of these are eventually used in technologies, and many of these technologies are technologies that we use every day. Okay, now that was my talk on applied mathematics. Now I go to pure mathematics. I go back to my first love. Alam ba niyo yung prime number? Prime number, of course, are numbers that you cannot divide. The numbers that only that have factors. Prime numbers are numbers that only have two factors, one in itself. So these are the first 7 prime numbers: 2, 3, 5, 7, 11. We know that 10 is not a prime number because 10 has factor 2 and 5. But these numbers are indivisible. Prime numbers are important because every number, every integer, every positive integer greater than 1 is a product of prime numbers in a unique way. So sabi nila, the prime factors of a number actually give you all the information about that number. The prime factorization of a number gives you the atomic structure of that number. So for example, if I want to study the number 72, what will I do? I will factor 72. 72 is equal to 2 times 2 times 2 times 3 times 3. No other number has that combination of prime numbers. So everything I need to know about the number 72 is contained in that combination of 3 2s and 2 3s. The question is, how many prime numbers are there? This was an old problem that was answered by the Greeks. Sabi ni Euclid, that's way back 300 BC, sabi niya, infinitely many. Madaling ipakita to. Hindi tayo mauubusan ng prime number. Sa bawat prime number na mahanap nyo, makakahanap pa tayo ng mas malaking prime number. Isang tanong, is every even number greater than 2 the sum of 2 primes? We can check for the first, we can check as far as we can go. 4 is 2 plus 2, 8 is 3 plus 5, so the sum of 2 prime numbers. 100 is 29 plus 71. Again, prime numbers. Ang question is every even number the sum of 2 primes? This we do not know the answer to. This is called the Goldbach conjecture. We can test for a finite number of even numbers. Well, alam natin that there are infinitely many even numbers, so we cannot possibly test everything. So this is a problem in theory. No one knows yet. This is a very famous problem. If you can prove this, if you can find the answer, you will be very famous. A twin prime is a pair of primes that differ by 2. Halimbawa, 3 and 5, 5 at 7, 11, 17 and 17 and 19. All of these are twin primes. 801 and 803 are twin primes. The question is, how many are there? Now, there is a conjecture, may hula, that there are infinitely many twin primes. Again, no one knows the answer. Now, this is a very difficult problem. Many mathematicians have tried solving this. No one has been successful. There was a big breakthrough in 2013. This guy, Yitang Zhang, proved that there are infinitely many pairs of primes that differ by a bounded gap. Bounded gap. Ang sabi niya, actually, pinakita niya, there are infinitely many primes that differ by a gap of, I think that was 70 million. Malaki. Pero yung 70 million na napaliit na palit. Ang gusto natin pakita that there are many pairs of primes that differ by 2. But the techniques of Yitang Zhang were very revolutionary to be able to put a bound to that gap between pairs of primes. Is very important. Sa mathematicians kasi, as long as compared to infinity, a number as big as 70 million is already very close to 0. Any big number is actually a small number because if you compare it to infinity, everything is small. Is there a perfect cube other than 27 which is larger than a perfect square by 2? Ibig sabihin, can I find a perfect cube which is 2 more than a perfect square? Now, of course, 27 perfect cube, no? 3 times 3 times 3 is 2 larger than 25, which is a perfect square, 5. Sabi ni, ito, si Fermat, sabi niya, meron pa bang iba? No? About 50 years after this, after Fermat, the great mathematician Euler says that there is no other pair of squares and squares and perfect cubes that differ by 2. These are the only ones. A general question: if you have a polynomial, any polynomial, you know, for what values of the unknowns is a polynomial equal to 0? Now, of course, we use this in algebra, in calculus, etc. For example, if you have the equation x squared plus y squared is equal to z squared, for what values of x, y, and z does this equation give you 0? Mula pa sa panahon ni Pythagoras, alam natin na infinitely many. No? Halimbawa, 3 squared plus 4 squared is equal to 5 squared. 5 squared plus 12 squared is equal to 13 squared. Marami itong solution. Bago pa sa panahon ni Pythagoras, alam na ng mga Babylonians, no? 2,000 years before Christ, that we can generate solutions to the equation x squared plus y squared is equal to z squared. Yung etong parang archaeological relic na nakikita nyo dito ay ito yung Clinton 332. It's an archaeological find, very old, but it actually contains, it has a table of numbers. And these numbers represent solutions to that equation x squared plus y squared is equal to z squared. So now we know that x squared plus y squared is equal to z squared has many solutions. Again, by a solution, I mean a set of numbers x, y, and z that satisfy this. Now, if we increase the exponent to 3, what is the answer? Do we have many solutions? Euler in the 18th century showed that if the exponent is 3, there is no solution, except for, except if one of x, y, and z is 0, then we have infinitely many solutions. But we cannot find, we will never be able to find non-zero integers x, y, and z that would satisfy this. This is a very deep problem, and Euler actually used imaginary numbers to be able to arrive at a proof that the equation has no solution. Now the question is, if the exponent is increased to any number greater than 2, 3, 4, 5, all the way to infinity, may solution ba? This guy, Fermat, in 1637, conjectured, he stated that sabi niya, wala daw solution. Pero conjecture dahil wala siyang binigay na patunay, wala siyang binigay na proof. This is a very famous problem. It was unanswered for more than 500 years. It was conjectured by, no, not 500 years. This is more than 300, maybe 357, 8 years. 358 years. Conjectured by Fermat in 1637, it was proved by Andrew Wiles in 1995. It was this problem that actually inspired me to go into mathematics, to do my master's and my PhD in mathematics. I was very fascinated with this problem. Very simple to state, but very deep and very difficult to prove. Another question: when is a given expression a perfect square? Now, for example, for what values of n is 2 to the exponent to the power n minus 7 a perfect square. The Indian mathematician Ramanujan conjectured without proof that this has solutions only for 5 cases, 3, 4, 5, 7, and 15. Madaling pakita na 2 to the 3 minus 7 is 1, so a perfect square. 2 to the 4 minus 7 is 9, a perfect square. But are these the only values of n that would give you a perfect square? That is a deep problem. Ramanujan conjectured this, but it was proved after many years by the mathematician Nagel. In fact, now we know, and this is because of Ramanujan, that if we, instead of 7, if we look at other values of b, 2 to the y squared is equal to 2 to the n minus b has solutions for at most 2 values of n. So if we replace 7 by any other number, the number of values of n that would give you a perfect square will not exceed 2. It's only for 7 that you have 5 different solutions. These are problems in number theory. Ito, pure mathematics, wala siyang application. Pero yung mga technique na ginagamit para ma-solve ang ganitong klaseng problems ay napakalalim at ito yung maraming application. Suppose I have a polynomial equation. Again, ang question is, what are the solutions in Z? What are the integer solutions? Or we can expand that. Are there solutions in rational numbers? So these are the types of questions that have led to the growth of number theory. By solutions, we in number theory we call them points because eventually we translate this into numbers in geometry. So if I have an equation, I want to ask, are there points on these equations? In geometry, we will interpret this as curves. For example, in a parabola is defined by an equation, but it's actually a curve. A parabola is a 2-dimensional curve, but here we look at n-dimensional curves. In a sense, we are expanding, we are generalizing the concept of a curve. When I have a solution, whether in integers or rational numbers, then we say that there exists solutions, there exist points in the curve. A number theorist would not only look for the solutions or the points in the curve, we want to look whether there is a certain structure to the points in the curve. We also have computational problems, like if I have one solution, if I have one point, can I find the other ones? Can I compute the other? Can we compute the other points? This is again a computational number theoretic problem. Okay, in algebra we do this for curves of degree 1 or 2, lines and parabolas, quadratic equations. But we can actually expand, what we mean by finding solutions or points in the curve when we look at generalizations of polynomial equations. In general, we do not have to limit our points to those having integer coordinates or having rational number coordinates or having real number coordinates. We can look at bigger sets of numbers. Here we enter the world of abstract algebra. For this equation, I will not go into details, but in general, the general question is, if I have an equation like this, for what pairs of integers x and y, is this equation satisfied? This equation, we say, actually represents what we call a hyperelliptic curve. So I'm looking again, if I have values for the a sub n minus 1, etc., then my interest is looking for the points represented by pairs of numbers x and y. Halimbawa, itong equation na to, kapag ang hinahanap ko ay real number points, I can graph it in the Cartesian plane. Sa calculus, sa algebra, hindi tayo lumalabas sa Cartesian plane. So usually ang hinahanap natin ay points with real number coordinates. So ito yung graph niya. Instead of real numbers, we can actually look at complex numbers. So for example, for this equation, x squared plus x cubed, y squared plus x cubed is plus ax plus b. By some mathematical, if I want to look at the complex points that satisfy this equation, by some geometric transformations, I can actually describe all those complex points as a donut. Hindi ko na papaliwanag. Pero actually pwede itong imagine na nakapaglaro na ba kayo nung game na Snake? Ito yung merong bulate na paikot-ikot sa screen. Pero kapag sa screen, kapag halimbawa yung bulate tumama siya sa kaliwa at tumama siya doon sa kanan, yung kanan na border, hindi siya tatalbog, kundi lalabas siya doon sa kaliwa. O kaya kapag yung bulate paikot-ikot tumama sa taas, imbis na tumalbog siya, ang gagawin niya, lalabas siya doon sa baba. Ang ibig sabihin nun, yung left and right border pareho, yung top and bottom border pareho. So ang ginagawa natin, yung kapag ito yung square na pink na yan, dahil yung top at bottom pareho, pwede nating pagsamahin. Then we form a tube. Because the left and right border are the same, we can bend the tube and connect the ends. And then we get what we call a donut. In Riemannian geometry, this is called a surface with one hole, or genus 1. So topologists will look at curves like this in terms of the number of holes they have. Pero yung game na Snake, yung paikot-ikot na bulate, actually, hindi siya umiikot-ikot siya, hindi sa isang infinite plane, kundi sa surface ng isang donut. So if we have equations, we can visualize them as curves. And an elliptic curve has one hole, so we say with its genus 1. The green curve here has genus 2, etc. In 1984, this German mathematician proved a very important theorem. Ang sabi niya, a curve with genus greater than 1 has at most finitely many rational points. Ibig sabihin, hindi aabot ng infinity. Hindi gaya halimbawa ng parabola. Ang parabola, infinitely many rational points. Pero kapag ang genus nito ay greater than 1, then we have only finitely many rational points. Pwede ba magtanong, are you following me or are you masyado bang mabilis? No. This is a photo of Jared Faltings.
Sakto lang, sir. Okay lang po.
Ako lang ba nag-enjoy dito? Kayo rin?
Madami po sir nag-enjoy. Especially po sa department ng math.
Ngayon, okay.
Thank you po.
Yung kanina, yung sabing Fermat curve, x to the n plus y to the n is equal to z to n. No? Ang implication nito, ang ginawa ni Faltings, ang sinabi niya, actually, kung may solution ng Fermat curve or Fermat equation, no? Kung may solution, at most finitely many lang. Hindi pwede maging infinite. Napakalaki. Ang sabi ni Fermat, in fact, walang solution, zero ang number of solutions. Ang sabi ni Faltings, kung meron man, hindi abot ng infinity. Malaking bagay na yon dahil ibig sabihin, finitely many, it has an integer. The number of solutions is a non-finite number. And that non-finite number, no matter how big, it's very small. It's very close to zero when compared to infinity. Okay. So I will skip this. Again, this is an elliptic curve, any equation that can be represented by y squared is equal to x cubed plus ax plus b. Again, if we look at the complex points, we can represent this as a surface of a donut. If we have, this is an elliptic curve, yung pula, but I can define a certain addition operation. For example, if P and Q are points in the curve, we extend that line because this is a cubic curve. The line will intersect the curve at another point. And then if I reflect that down, ito yung dotted line, I reflect the third point of intersection, and then by drawing a perpendicular line, a vertical line, that vertical line will cross the curve at another point. I will define this as my P plus Q. So isa tong, I've defined a certain way of getting a sum of rational points. And mathematicians, when they have a set of points and they define an operation, they look at the structure of that set under that operation. And in higher algebra, we have what we call a group. A group is a structure of a set. And if we know the group structure, then we can answer so many things about the set. In this case, I'm looking at the curve and I'm looking at the set of points on the curve. Ang sabi, this guy in Mordell in 1922, ang sabi niya, the rational points of an elliptic curve form a certain type of structure called a finitely generated abelian group. Alam to ni Ningning Rosal. There are, okay, itong equation sa ilalim, ito yung structure ng group. At sa bawat curve, mayroong isang numero na associated with that curve. Ang tawag natin dito, the rank of that curve, no? Yung R. I will not explain. I just want to say later that rank R contains a lot of secrets about the group. So if I have an elliptic curve, I would want to know what that R is. Actually, finding that R is very difficult. Okay, that R, ito yung sinasabi ko. If I have a random curve, a random elliptic curve, there's no known method for computing the rank of that curve. Very difficult. For specific curves, we can compute R, but for any random R, there's no known method for computing that rank. This is the subject of a lot of important research in number theory. I will skip this, but these are mathematicians that have done very good work on elliptic curves in the past 20 years. A big breakthrough was achieved by this Indian mathematician, and for his work, he was given the prestigious Fields Medal in the International Congress of Mathematicians in 2004. I will skip this. But my point is that if I have an elliptic curve, okay, I want to understand that curve, the secret of that to everything about that curve. lies in that number R. Okay? So, ang tanong, paano nga ba kinocompute yun? Mahirap. No? Merong isang conjecture in 1960, ang sabi nila, to understand R, you need to understand the behavior of a certain complex function associated with the elliptic curve. Manipulating that complex function of the curve is actually computationally easier. So, ito yung sinasabi niya. Pero, yung link na yan ay hindi na-prove. The proof to that is what we call the Birch and Swinnerton-Dyer conjecture. It is a very famous problem in mathematics. It is unsolved. And there's an institute in Canada that has offered $1 million for the proof of the Birch and Swinnerton-Dyer conjecture. Okay, why do we study elliptic curves? First, well, one, the solution. I talked about Fermat's last theorem. The solution, the proof in 1995 to Fermat's last theorem actually used the theory of elliptic curves. Again, elliptic curves, these are very deep concepts that are very powerful, that can be used as very powerful mathematical tools. In this case, these are mathematical tools to solve problems in other areas of mathematics. Okay, I go to a very old question. It's called the congruent number problem. If n is a positive number, okay, n is a positive numbers, makakahanap ba ako ng rational numbers, no? Fractions, r, s at t, such that r squared plus s squared is equal to t squared, and r times s is equal to tn. If you look at this triangle, if r and s and t, this is a right triangle, if r and s and t are the dimensions of the triangle, t being the hypotenuse, dahil right triangle siya, alam natin r squared plus s squared is equal to t squared. At ang area ng triangle na to is r times s over 2. In other words, r times s is equal to tn. Kaya ang tanong dito, if n is an integer, makakahanap ba ako ng isang right triangle na ang area niya equal to n? Pero ang kanyang dimensions ay mga rational number. Hindi to madaling question. Una tong tinanong ng mga Arab geometers, no? At least 1,000 years ago. Halimbawa, alam natin if n is 6, then we can find such triangle because the 3, 4, 5 triangle has area equal to 6. If n is equal to 5, it is difficult to find the dimensions of the triangle, but we can actually compute that. For example, this rational triangle, I call it rational because the sides are rational numbers. 41 over 6 hypotenuse, and the sides are 20 over 3 and 3 over 2. If you compute the area, this is area exactly equal to 5. Now, it's not easy to find these rational numbers. If n is 157, no, finding the, hindi nag-align ng aking mga numero, but finding the value of r, s, and t is even more difficult. Now, this is the smallest solution. If the area of this triangle is 157, I can compute r, s, and t. And r is this fraction, s is equal to this fraction. Not easy. Now, the question is, if n is any number, the question is, can I find such a triangle such that the sides of the triangle have rational number sides and the area is equal to n? If there is such a triangle, we call this number a congruent number. So, ang 6 is a congruent number. 157 is a congruent number. 5 is a congruent number. In fact, Fibonacci in 1225 showed that 5 and 7 are actually congruent numbers. He computed these rational numbers. Okay, these are rational, these are, if n are these values, then these are the rational numbers that form the triangles having n as area. 8 is not, 8, the numbers that you do not find here are not congruent numbers. Halimbawa, 10, wala dito. There, you cannot find a triangle with area equal to 10 and having sides equal to rational numbers. So in 1650, this guy Fermat showed that 1 is not a congruent number. This is the congruent number problem. It's an old problem with no solution as of now. Can we find a simple method that will tell us whether a given integer is congruent or not? This is very difficult. I will skip this. This is a very big breakthrough in 1983. But again, the answer to that question is still not known. Now, what is nice is that the problem of congruent numbers is actually a problem in elliptic curves. I will go straight to the theorem, at the theorem. If I have a number, I want to know whether it is congruent or not. What I need to do is to look, if the number is n, I will need to look at the elliptic curve y squared is equal to x cubed minus n squared times x. Sabi dito, n is a congruent number if and only if the elliptic curve has, okay, I will rephrase this. If and only if the elliptic curve has positive rank, has rank not equal to 0. So the ancient problem of determining congruent numbers is now translated into modern mathematics in the language of elliptic curves. I will skip this. Again, this is the, I'm showing how the study of elliptic curves leads to answers about very old, very difficult, very deep mathematical problems. Okay, I will skip this. Actually, natutuwa lang ako, nakikita ko yung equation. Ito yung theorem. A given number n is congruent if and only if the elliptic curve has positive rank. When I was studying, I did a lot of work on this problem. These are some of the results. I did a lot of computation and work on elliptic curves. But in our institute in mathematics, we also do a lot of work on elliptic curves. I do this with my students. We do rank computation. We do a computation of structures and curves, etc., etc. We also do applications of curves. Itong discrete log problem on elliptic curves is a problem connected with cryptography. I'll go back to that later. Ito yung Birch-Swinnerton-Dyer problem. This is the complex function that I said can be associated with every curve. There is a link between this function and the elliptic curve, the rank of the elliptic curve, but no one has clarified what that link is. So that clarification, that proof, is what we call the Birch and Swinnerton-Dyer conjecture. It's a very difficult problem, and the solution of that problem carries a prize of $1 million. Ito yan. Sabi ko sa mga students ko, mas madaling magtayo ng isang kumpanya gaya ng Facebook. Kung gusto nyong kumita ng $1 milyong, mas madaling magtayo ng isang successful internet company kaysa sa mag-solve na isang mathematical problem. So alam natin na mga mathematician na gumagawa ng ganitong klaseng research ay hindi pera ang habol nila. Dahil kapag pera ang habol, magtrabaho ka na lang sa isang kumpanya. Malalim ang mga problems na to, pero masaya para sa mga mathematician dahil maraming na-unfold ng mga sikreto kapag tayo gumagawa ng mathematics. Why do we study elliptic curves? We want to solve mathematical problems. There are certain computational methods for factoring big numbers using elliptic curves. Now, a most very recent application in the last 20 years has to do with information security. In fact, in 2005, meron isang area ng cryptography is the mathematics of computer security. Marami sa mga secure computer protocols ngayon, encryption protocols ay gumagamit ng theory ng elliptic curves. In fact, in 2005, ito ang sabi ng US National Security Agency. The best assured group of new encryption techniques is built on the arithmetic of elliptic curves. Kaya sabi nila, in fact, we should move from first-generation public key algorithms to elliptic curves as the foundation for future internet security. Kapag kayo gumagamit ng mga applications like WhatsApp or Chrome or Firefox, Opera, ito mga browsers to, at the WhatsApp of course is a communication platform. You are probably using, in fact, you are using elliptic curves dahil dito sa mga bagong mga platforms, elliptic curve cryptography na ang ginagamit nila for securing the information that you transmit through these platforms. But of course, for mathematicians, the main reason why we study elliptic curves are deep and beautiful mathematical structures. So we find them challenging, but doing mathematics has always been a lot of fun. This is my last slide. Okay. I just want to show you the title of my next lecture. Ang sabi kasi ni Dr. Jackie ay dalawa ang bibigay kong lecture. On December 3, I will be giving a talk on complexity theory, math and complexity in nature and society. Okay. Maraming salamat po.
Thank you, Dr. Nemenzo. Now, we're open for the open forum. For those who have questions, kindly put it in the chat box.
Okay po.
So, Sir Edcon, what are the questions that we have?
Okay, ito po yung mga tanong na first question po from Jose Alejandro Constantino, Lara. Is there any thesis topic in continued fraction or Pell's equations that can recommend by Dr. Nemenzo to future research, sir? Researchers like me. Po sabi ni Sir Lara.
Marami Pell's equation, continued fractions. Yes, marami akong ma-recommend na thesis problems. Ang Pell's equation pala ay related sa isang algebraic structure called a real number field. Maraming mga very interesting problems dito. Hindi lang sa Pell's equation, kundi mga generalization ng Pell's equation. Pero kailangan mag-aral ng group theory para dito.
Okay, sir. Thank you.
Thank you po. Ito po yung other question po from Pat Malaya. As a pure mathematician doing applied mathematics, which do you find more enjoy in doing, pure or applied? What advice can you give to those who are not sure if there is joy behind pure math?
Ano ba mas gusto ko, pure applied? Siyempre, pure mathematician ako, pero sabi ko nga nitong nakaraang 10 taon ay nag-enjoy sa applied mathematics. No? Ngayon, hindi ko na pinaghihiwalay ang dalawa. Dahil ang applied mathematics ay nakatungtong din naman sa foundations made of pure mathematics. Ang problema kasi nito minsan na nalulunod tayo sa mga equations at numbers, no? Pero maganda na magbasa tungkol sa mathematics na nakatulong sa akin halimbawa sa mga libro bukod sa mga textbook na at mga mathematical journals na rene-require, nakatulong sa aking pananaw sa matematika ang pagbabasa ng history, ng literature dahil maraming koneksyon ng mathematics sa iba't ibang aspeto ng mundo. Nature, for example, contains a lot of mathematics. Kapag nakikita kasi ito, parang nakakatuwa parang hindi lang pala numero, hindi lang pala mga equation, kundi ang mga equation na to ay mga description ng mga magagandang bagay na nakikita natin sa araw-araw na buhay. So bilang mathematician, napakalaking tulong sa akin bukod sa pag-aaral ng matematika ang pagbabasa na labas sa curriculum.
Okay, thank you, sir. Our next question came from Marlu Fabia, and he's asking what are the criteria to be considered in assessing a best fit or not a perfect fit data in curve fitting analysis?
Hindi ko naintindihan. Ano yun?
Ano daw po yung criteria to be considered in the assessing if it's best fit or it's not a perfect fit in curve fitting analysis?
No, sorry, hindi ko alam ang curve fitting analysis. I mean, may alam ko pero hindi ko area.
Okay.
Okay, thank you,
So
sir.
this is not a question but rather a comment from Sir Ken Lugid, and he's very grateful. He said, "Hi Sensei, you will always be my first lab professor. I did not leave the BS Math because I started loving it in our FCM and number theory class."
I can.
So, sir, for the other question, how would you encourage yung young people now to engage in BS Math or BS Mathematics? Kasi some people are afraid of math.
Numbers, yes.
So ano po yung advice niyo, sir?
Ang advice ko, magbasa, buksan ng pag-iisip. Ang mathematics ay hindi lamang makikita sa libro, hindi lamang sa numero, hindi lamang sa loob ng classroom. In fact, kahit saan tayo tumingin, nakakita tayo ng mathematics. Like ang sabi ko, an educated person does not need to understand the mathematics. But you have to know that it's mathematics that powers this world. It's mathematics that allows us to make sense of pattern. Sa totoo lang, ito na sinasabi ko sa mga students, lahat tayo, whether you like mathematics or not, every day we do mathematics. We do computations. When we look at money, we compute. We make decisions. When we make connections between two different things, we are using our mathematical mind. When we use logic to make decisions. When you want to find the best route towards a certain destination, you employ a lot of mental techniques, and one of them is a mathematical mind. So hindi siya nakakatakot dahil araw-araw natin ginagamit ng mathematics.
Okay, sir.
At sabi ko, personally, malaking tulong sa akin ang pagbabasa. Dahil reading expands your mind, whether it's mathematics or not. But you'll see that every field of study is actually very interesting, and one of them is mathematics. If you read history, the history of culture, the history of the world, a lot of the things we have now, a lot of ideas, came from ideas in philosophy and mathematics. So ayun lang, basa at dapat bukas ang isip. And that the mathematics that para kayo nagbabasa, para makapagbasa ng isang magandang nobela, kailangan mo na mag-aral ng konting grammar.
Yes.
The math that we study in school is actually the grammar of mathematics. These are all building blocks. Of course, the literature is pure and applied mathematics, mathematical research, but there are now a lot of areas that use highly quantitative skills, and a lot of these a lot of these use a lot of mathematics. Nakikita ko dito sa chat maraming tanong. Ano nga ba ang relevance ng pure math sa statistical analysis? No? Statistical analysis is really based on pure math. No? When we talk of probability theory, we use the calculus, we use differential equations. Many of the math we use in statistics and engineering used to be part of pure mathematics. Ano tong MMW?
Mathematics in the modern world po.
Ayan, mathematics
yes.
in the modern world. It's a good move by Chet to make students appreciate mathematics. Oh yes, because mathematics in the modern world is general education mathematics. Here, you do not learn deep mathematics, but you learn how to appreciate mathematics. Sabi ni Ken, there are computer algorithms to check how good a curve can approximate a data set. Tama? Numerical analysis and data science are courses where this can be learned. This is, of course, data science is a very sexy field right now. Data is a very powerful currency. Sabi nga nila dati in the 20th century, it was the main currency. I mean, of course, money and oil are the currency, but in the 21st century, the power of your organizations, it's really a function of what kind of data you have, what kind of data you control.
Yes.
And my next talk on complexity will also touch on this.
Okay. Sir, thank you. Meron pa pong isang tanong. Sir, meron na po bang known proof na by construction ang model conjecture besides doon sa proof ni Faltings from Althusserberg?
Sino ba to si Althusserberg? Si Selberg ay isang famous mathematician. Natutuwa naman ako na nandito siya, pero alam ko matagal na siyang patay. Walang known proof ang proof ni Faltings. This is a purely existential proof. No? Ang sabi niya, kapag given a curve, hindi niya pinakita kung ano ang upper bound to sa number of solutions. Pinakita lang niya that there is an upper bound. Ang ganito, halimbawa, papasok ka sa isang madilim na kwarto. Ang pinakita ni Mordell ay kahit madilim, merong tao dyan. Ang tinatawag na proof by construction, no? Asa ng tao, anong itsura ng tao. Ang sabi ni Faltings sa ngayon, hindi pa natin mapapakita yan. Pasok ka sa madilim na kwarto, mapapakita ko na may tao sa kwartong yan. Maganda sana kapag may proof by construction. Maganda sana kapag pumasok ka sa kwarto, alam mo kung saan nagtatago yung tao. O alam mo anong itsura ng tao. Pero sa ngayon, wala pa.
Okay, thank you, sir. Ito po hindi siya question pero this comment, no? Sabi niya, hi everyone, good morning. Proud to be one of his students in numerical analysis in PUP way back 1987. Si Sir Ronald Fernando po.
Hey, Ronald.
Yan po.
Nagpakita kanina ng letrato. Nasa tubig kami, mga lalaki nagiinuman yata sa may beach. Kaya wala sila doon sa letrato.
Okay.
Nandun siguro si Ronald.
Okay, sir.
Yun lang po. Wala na po sigurong tanong, no? Yun lang po. Salamat po, sir. Sa napaganda po ninyo talk.
Sa letrato.
Maraming salamat po.
Nandun siguro si Ronald.
Yun lang po. Wala na po bang tanong? Yun lang po. Wala na po sigurong tanong, no? Yun lang po. Salamat po, sir. Salamat po, sir. Po ninyong talk. Sa napaganda po ninyong talk. Maraming salamat po. Yun lang po. Wala na po bang tanong? Yun lang po. Wala na po bang tanong? Yun lang po. Wala na po sigurong tanong, no? Yun lang po. Salamat po, sir. Salamat po, sir. Let me call on Professor. Maraming salamat po. Let me call on Professor John Patrick Santa Maria. Wala na po bang tanong? For the hypnosis. Salamat po, sir. Sir John Patrick. Salamat po, sir. Let me call on Professor. Let me call on Professor John Patrick Santa Maria.
Hello, narinig niyo po ako?
Yes?
Yes, sir. Yes, sir.
Medyo
Feedback.
nag-repeat yung audio ni Sir Edcon.
Okay, oo nga. Session.
Okay, good morning everyone. I'm here to give a summary of the talk of Sir Fidel. Actually, yung talk ni Sir Fidel parang overview ito ng number 3 and algebraic geometry class niya sa UP. Lalo na yung mga naka-enroll na, so makaka-relate. The beginning of the talk started with discussion of what the true nature of mathematics is. We have learned that math is not only about numbers, and it's actually about making sense of patterns as it reveals the secrets of nature. But aside from its abstract nature, math is extremely useful. It can be used to solve real life problems such as yung COVID pandemic natin. We can model it using mathematical models like differential equations to predict and to be able to plan ahead. Also, ngayon ko lang din po natutunan na yung cardiac arrest is actually a topological problem. That's very nice to learn. Then, Sir Fidel discussed the prime numbers, which gives the atomic structure of every integer greater than 1. With the prime numbers, they open up a lot of problems in number theory, such as the Goldbach conjecture, twin prime conjecture, and so on, which are actually special cases of a more general problem leading us to solve for the zeros of polynomials, in particular the rational zeros of polynomials. And then we learned about the Pythagorean triples, where it can be generalized to a harder problem, which is what we call the Fermat's theorem, which is actually the motivation of Sir Fidel. That's why he became one of the mathematicians right now. Then we have learned about the Diophantine equations over the rationals and over the integers. And then as a particular case, we studied elliptic curves as a particular example. We have learned that elliptic curves are not just curves when you try to expand the domain to the complex numbers. We see that it can become a Riemannian surface, such as the donut. And then we have learned that the points in the rational points in the elliptic curves forms a group under a certain operation, which leads us to the concept of the rank of a curve. And we have learned that this rank is very difficult to find, and there is no actually known method to calculate the rank, which opens up a lot of other relevant problems in mathematics, such as the Birch and Swinnerton-Dyer conjecture. And next, we studied why we have to study elliptic curves, because elliptic curves can be used to a lot of other mathematical problems, such as prime factorization and cryptography. Now, for spectators, mathematics seems to be so useful, but for mathematicians, we have learned that it's not only useful, but it's also fun. Yun yung tumatak sa akin sa lecture ni Sir. That's all po. Sir Edcon.
Okay, thank you, sir. So at this
That's
point,
all po.
let's proceed to the awarding of certificate. And to award the certificate to our guests of honor for today, may I call on the Director of the Research Management Office. Okay, thank you, sir. So at this point,
That's all po.
let's proceed to the awarding of certificate. And to award the certificate to our guests of honor for today, may I call on the Director of the Research Management Office, Dr. Jackie Urucha. Sir Jackie.
Hello, ma'am. Good morning. Sir Fidel, thank you so much for your wonderful lecture. Let me read this citation. Polytechnic University
of the Research Management Office, Dr. Jackie Urucha. Sir Jackie.
Hello, ma'am. Good morning. Sir Fidel, thank you so much for your wonderful lecture. Let me read this citation. Polytechnic University
of the Research Management Office, Dr.
This
Jackie
certificate of recognition is
Jackie.
given to Chancellor Fidel Nemenzo, Sir Fidel, thank you so much for your wonderful in grateful acknowledgement of his distinguished Polytechnic and invaluable service rendered as guests of honor. This speaker certificate of recognition is given to Technology Professorial Chair Lecture Series 2020. Grateful acknowledgement of his distinguished and invaluable service rendered as guests of honor. This speaker numbers and curves given this 26th day of November 2020 at the PUP main campus in Santa Mesa, Manila, Philippines. I, Dr. Manuel Service, University as guest of honor. Thank you so much, Sir Fidel. Curves given this 26th day of November 2020 at the PUP main campus in Santa Mesa, Manila, Philippines. I, Dr. Manuel Service, University as guest. Thank you so much, Sir Fidel. Numbers and curves given this 26th day of November 2020 at the PUP main campus in Santa Mesa, Manila, Philippines. I, Dr. Manuel Service, University as guest. Thank you so much, Sir Fidel. Numbers and curves given this 26th day of November 2020 at the PUP main campus in Sir Edgon. Jo.
Yes, sir. Okay, Sir, Sir Jackie, thank you very much po, no? For the evaluation, please click po yung link, no? Yan, http.bit. Ipopost na lang po dito sa chat box. Ayan po. Pasuyo na lang po, no? Yan, until 11:59 PM today. Okay po.
Okay.
Okay, muli po sir, maraming salamat po, no, sa pagbibigay ninyo pagpapalak. Please open po yung ating camera, no, para po sa ating picture opportunity. Okay. Okay, for our future webinar, ito po yan, no? Please see your screen. Ayan, sa December 3, no? Talk po ni Sir Nemenzo, please attend po tayo. No? Then on December 11, si Dr. Ryan S. Evangelista. Okay.
Also, we have the upcoming event of the Open University System, Sustainable and Healthy Spaces Through Well Building Standards, to be conducted by Engineer Ryan Ben Sabilala. So kindly see the link below or the QR code to participate. So everyone, kindly open your cameras for the photo opportunity.
Hello po, good morning po. Paki-open na po yung camera po natin. So may 7 po tayong slides. Sa first slide po muna tayo magte-take ng picture. So, okay po. Magka-count po ako ng 3, then magte-take ko ng picture. Okay po. Sa first batch po tayo. 1, 2, 3. Okay. Okay po.
Next
Second
po.
batch po. Okay po. 1, 2, 3. Okay po. Third batch po. Okay. 1, 2, 3. Okay po. Next batch po. Okay po. 1, 2, 3. Thank you po. Okay. Next batch po tayo. Okay po. 1, 2, 3. Okay po. Next batch po. 1, 2, 3. Okay po, last batch na po tayo. Okay, 1, 2, 3. Okay po, thank you po. Okay na po, ma'am.
Okay. Thank you everyone for participating. And to close our program for today, may I call on the Dean of the Institute of Technology and currently our Faculty Regent, Engineer Ramir M. Cruz.
Good morning to all the um, officials of the university, especially Dr. Manuel M. Muhi, present po yata siya dito. And from the College of Science and College of Engineering, magandang umaga po. Thank you very much, Dr. Nemenzo, for that very insightful lecture. And we are looking forward doon po sa susunod ninyong lecture sa PUP. We have a love-hate relationship with numbers, no? I suppose. Kami pong mga nasa College of Science and College of Engineering. We very much love the number 1. We hate number 5, no? And we celebrate number 3. I think everybody would agree with that. But then again, kidding aside, sabi nga po ni Mr. Dubois, when we have mastered numbers, no, we will be in fact no longer be reading numbers anymore. Then we read words when reading books. We'll be in fact reading meanings, no? And meanings are very important to us. We develop models, no? And as Dr. Nemenzo had said, no, these models would lead us to solving the many problems that we are facing right now that requires us mathematical and technological solutions. No? So with that, I think everybody would agree that we really love numbers, no, and mathematics for that matter. So again, Dr. Menzo, thank you very much po sa inyong napakagandang lecture. And we will be using these learnings for us to be able to advance our goals, no, in becoming a National Polytechnic University. So again, maraming salamat po to all the attendees. Maraming salamat and see you again sa susunod po na mga lecture series. Thank you very much.
Thank you, Sir Ramir. So at this point, kindly let us sing the PUP hymn. At this point,
Hello,
kindly
before we
let us
proceed
sing.
to PUP hymn, I would like to recognize the following. President Manuel M. Umuhi, our President, Pangasinan State University, Mindanao State University, FEU Technology, the PhilSCA, National University, PUP College of Science, PUP Lopez, Cebu Technological University, UP Diliman, Biliran Province State University, Phoenix Garuda Constructions, Caraga State University, Alpha Mart Trading Philippines, Bukidnon State University, Igentech Corporation, Muntinlupa Science High School, University of the East, Caloocan, Philippine State College of Aeronautics, the Mechanics, Western Mindanao State University, Capiz State University, Universidad de Manila, Mariano Marcos State University, DOST, ITDI, Laguna State Polytechnic University, Fiati University, Pamantasan ng Lungsod ng Maynila, PIEP NCR, PSME Qatar, Cotabato State Polytechnic College, PUP Mathematics Club, Malayan Insurance, Cebu Normal University, PUP ITech, PUP College of Engineering. And let also acknowledge the presence of the parents of Dr. Nemenzo. Nakakatuwa po at nandito sila. And muli po maraming salamat sa lahat. Acknowledge the presence of the parents of Dr. Nemenzo. Nakakatuwa po at nandito sila. And muli po maraming salamat sa lahat.
Pangalanan ang langka ng bayan, bandayan ang isip ng kapatapan. Pag-ibig dumating na sa sayaman, pangalanan ang langka ng bayan, bandayan ang isip ng kapatapan. Pag-ibig dumating na
Sir Fidel, thank you so much po.
Salamat sa lahat.
Thank you po. Thank you po, Sir Dr. Fidel.
Salamat, Jackie.
Thank you, sir. Thank you. Salamat po. See you po again, sir.
President Bong, salamat.
Thank you po, sir.